Alright guys, so in this video what we're looking at is what we did today. Today we looked at multiplying and dividing rational functions, and we kind of started off the period looking at something like this, in which we were told that we wanted to simplify this expression to the greatest extent. So in this case we're looking at b squared minus 7, or 5b minus 36. And so we're looking at a product of negative 36 and a sum of negative 5. So I think that turns out to be like negative 9 and 4. So we have b squared minus 9b plus 4b minus 36. Just to factor it by grouping, we built a bridge between the first and the last term. And then we split the middle into negative 9b plus 4b. And we got a 4 that goes into those, and we have a b that goes into those. So looks like I got b is the greatest common factor, so I got b minus 9. And then I got 4 that goes into both of these, so I have b minus 9 as well. So the factored form in the numerator would be b plus 4 and then b minus 9. That would be the factored form of the numerator. Now in the denominator, I look at both of those. I look at 9b and I look at 36. 9 is the greatest common factor, so I got 9 times b plus 4 is the factored form of the numerator, or denominator. So what I can do is whatever is the same on the top and the bottom, very similar to like when we were talking about that point of discontinuity, I know both of those cancel each other out. So in this rational function, that's kind of telling us where that point of discontinuity is going to be, where b equals negative 4. But your factored form would be b minus 9 over 9. That would be your factored form in that case. So let's look at just another one right here. This one's a little bit more challenging, I guess. But if I were to factor this quantity out, I think I end up with 7r minus 2. And then I got r plus 8 is what the factored form is. And in the denominator, I do have a 5. If I factor out the denominator, I end up with r plus 8 and then r minus 1. And so whatever they have the same on the top and the bottom, I could cancel. So in this case, I got an r plus 8. They cancel each other out. So I end up with 7r minus 2 times 5 times r minus 1. So that's kind of where we started class. It's just looking at, we did a whole bunch of examples in which we just simplified some rational expressions to the greatest extent that we can. Now, like we're looking at the idea of addition and multiplying and dividing. So when we multiply rational expressions, there is no need to find a common denominator. That's this is really, multiplication is easier than addition because we don't have to worry about the finding a common denominator. Simply, all we have to do is multiply the numerators together and multiply the denominators together, then simplify. That's all we have to do. So let's look at this example. We have two functions. We have f of x and we have g of x. And I want to multiply them together. So I got x squared over 2. That is being multiplied by 12 over x. So we are going to multiply the numerators together. It looks like I got 12x squared over 2x. So we want to simplify this to the greatest extent of our ability. So we are going to look at 12 and 2. Those are both constants, so let's see, what's 12 divided by 2? It looks like that's 6. If I take x squared over x, I have 2 x's on the top, I have 1 x on the bottom. That leaves me with 6x in the denominator. So that would be your simplified form, 6x. So if we look at number 3, this is on page 10 of your notes that you guys got. We're going to do the same thing. We got 3x. And then we got x minus 2. That's being multiplied by 5x minus 10 over x. And one of the things that I like to do, just to kind of help make simplifying a lot easier, is anytime that I can factor out an expression, I'm going to try to do that. So I'm going to try to factor this out. It looks like 5 is the greatest common factor. So I can say it's 5x minus 2. So right now, I have 3x times 5 x minus 2, and that's over x minus 2 times x. So that's in the denominator. So in the numerator, I got 3x times 5, x minus 2, and in the denominator, I have x minus 2 times x. So let's see if we can try to cancel anything out that they both have in common. Looks like they both have x minus 2, so I can cancel those out. And it looks like I do have an x being multiplied. So if I look, looks like I just got a 3 and a 5, which turns out to be 15. That's your simplified form. Okay? Let's look at one more that deals with multiplication. So I got x minus 2, and then I got x squared minus 25. That's being multiplied by 2x squared plus 11x plus 5 over 6x minus 12. It's a bad looking x, but here's the reason why. So let's look at this. I'm going to factor out as much as I can. I know that x squared minus 25 is x plus 5, x minus 5. If I look at 6x minus 12, that turns out to be 6, and then I got x minus 2. So let's look at the numerator. I think it turns out to be, just to kind of expedite things, I think I get 2x, and then I got x plus 5. I think I get a plus 1 here. So I got 2x plus 1, x plus 5. So my simplified, or like at least so far my factored form, is x minus 2, 2x plus 1, and then x plus 5 when I multiply straight across. And that's all over x plus 5, x minus 5, and then I got a 6, and then I got an x minus 2. So I'm going to pull out my different color marker here and see what I can cancel. Anything that's the same, I have x minus 2, that cancels. X plus 5 cancels. So it looks like I end up with 2x plus 1 over 6 times x minus 5. That's what that, when I multiply, that's my simplified form. Now, I can do the same thing with division. And just remember, division is the same thing as multiplying by the reciprocal. So I can look at 2x, and right now I have 2x over x squared minus 9, and that's being divided by 5x squared over 2x minus 6. Now, the first thing that I would do is I would get rid of that division and just rewrite it as multiplication. So I got 2x, x squared minus 9, times the reciprocal of this, of 5x squared divided by 2x minus 6. So I got 2x minus 6 now in the numerator. I got 5x squared in the denominator. Alright, so next thing that we're going to do is just kind of factor to the greatest extent of our ability. So I think I get x plus 3, x minus 3 in the denominator. That's what that breaks down to be. And then I got 2x minus 3. So if I look at this factored form right now, I got 2x times 2x minus 3. And that's all over x plus 3, x minus 3, and then I got 5x squared. So I want to cancel as much as I can in my numerator and denominator. I got x minus 3, I got x minus 3. Those two cancel. And then I have an x in the numerator, I got 2 x's in the denominator, so that x cancels one of the x's out. And my final answer would be 4 over 5. X, and then x plus 3. Okay, let's just look at one more with division. Okay, so I have x plus 2. This is on the next page. X plus 2 divided by x. 3x plus 6 divided by x squared. So I got x plus 2 over x. I'm going to multiply by the reciprocal of this, which is x squared over 3x plus 6. There's only one quantity that I have that can be factored, and that is 3x plus 6. So I can say that's 3x plus 2. So I'm going to just replace that. So I have x plus 2. That's being multiplied by x squared over 3x, x plus 2. Now we're going to cancel whatever we can. Looks like I can cancel a couple things. I can cancel out the x plus 2's, and I have an x in the denominator, which cancels the square. And so it looks like I just end up with x over 3 as my simplified answer. Okay. Let's just look at one more. Let's look at number 12. Same idea. 2x, and then I have x plus 2. Multiplied by the reciprocal. I'm going to rewrite that as 2, and then I got x plus 2. I just factored out 2x plus 4. That's divided by x squared. So I'm going to cancel whatever I can. The x squareds cancel. And so right now it looks like I got 4x over x squared. The x cancels out the square, so it looks like I just end up with 4 over x. So your job, or what we were trying to do tonight, is trying to look at the notes. I want you guys to try to complete 9 through 17. This is the Cliff Notes, or the very, 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 very quick version of what we did today in class. If you have questions, don't hesitate to ask.